Okay, so, whoops, got it back. Okay, today we are going over the structure of the atom in chapter 4. So the overview is early ideas of the atom, defining the atom, how atoms differ, and radioactive decay. So, earliest idea was proposed by Democritus. He was the first person to do it, but Aristotle didn't believe him. Turns out he was actually right. But the actual study of the atom began in the 1800s with John Dalton. So it was a while till anyone actually did anything. Now, okay, so defining the atom. So the atom is the simplest component in an element. So if you look inside, you'll have, this is a carbon atom. It's composed of the nucleus over here, which is composed of the neutrons and protons, and then in the outside is electrons. I'm sure we already all know that. Yeah. Okay. So how atoms differ. So we have a very small periodic table here, but they are organized by the atomic number up here, if you look at hydrogen over here, and the atomic weight, which is, atomic mass is protons plus neutrons. And then if we look at isotopes, it's an element with the same number of protons but a different number of neutrons. And I'm telling you what an isotope is because atomic mass is not only protons plus neutrons, it's the weighted average of the masses from its isotope. So say if you have like carbon 14, if you have carbon 12, carbon 13, and carbon 14, they will take the mass from each of those and then average that. So that's why carbon is like 12.011. That's why it has so many decimals for its atomic mass. Okay. So now, new share, whiteboard. There we go. Full screen. Okay. So now we have types of decay. So there are 3 types, and that is, there's 3 types of radioactive decay. There are alpha, beta, and gamma. Just went on a mind blank right there. Gamma, there we go. So alpha, beta, and gamma. So let's get over here, and yeah, it's probably good enough. Sorry, there we go. So what is alpha decay? So say if you have a nucleus over here, there are 9 protons, 2, 3, 4, 5, 6, 7, 8, 9, and that means it would have 9 neutrons as well. We'll do green, nice Christmas colors. 6, 7, 8, 9. So alpha decay is when the nucleus becomes so unstable that 4 or 2 of each proton and neutron leave the nucleus. So say you got over here, they leave. And this, say you have an element, just a random element, and you have 18 as its atomic mass, you'll have 9 as its atomic number. So then with the alpha particle, this is an alpha particle over here, leaving, you'll have an atomic mass -4, so that'll be 14, and the number of protons will be -2, which is 7. So that's how it decreases. So let's go to beta decay. So erase all this. Okay. So, same drawing again. Let's just do 7 for now. 1, 2, 3, 4, 5, 6, 7. And 7 neutrons as well. 2, 3, 4, 5, 6, 7. So beta decay is when either, well, the first example we'll do is a neutron. Say it wants to become a proton. It'll expand or emit 1 electron over here. Neutrons have electrons, very weird. So it'll emit 1 electron to become a proton over here. So emitting electron, and it'll become a proton. That's a great drawing. Okay. So then that will increase its atomic number by 1, and its atomic mass will stay the same because nothing was added or went away. Okay, and then the other example is of a proton wanting to become a neutron. So, sorry, getting the colors. So, proton wanting to become a neutron, it will emit not an electron, but a positron over here. So it'll emit a positron, and then it'll become a neutron. There we go. And this will do the same thing to the atomic mass and number as the neutron becoming a proton. So, yes. And then with gamma radiation, it's where these become like so close together, the protons and neutrons over here, they're just like really, really close. And that closeness expands a lot of energy, which is stronger and can go through more things than beta and alpha radiation. So that's pretty much it about atoms. Yeah, that was chapter 4, I think.